Trying to prioritize my real estate here. Don't have enough room. So I'm a bit early today. We still have 10 minutes more before the live stream officially begins. So I thought, I was just sitting down. Might as well just go online. Go live. Not sure if anyone's out there. If you are, say hi. Then if you have any questions, this is perfect time. You can squeeze in a question during this period, and I can try and fit it in the 10 minutes. Let me turn this on. You have something nice to look at. Hi, Nabi. Hello. So this is what we're making today. Not the texture though. This is what we're going to be making today in Houdini. I'm only using Blender to display it because Blender's rendering engine is very fast. So this is the geometry that we're going to be making in Houdini using the Vellum tools, the Vellum Drape. Very simple, simple vest. If you've seen some of my Twitter feeds, tweets lately, I actually put sleeves on this vest. But this, after adding the sleeves, it made the network really large. And it's adding the sleeves is like a repetitive technique that I'm going to show you today. So you can actually use the techniques I'm going to show you today to add the sleeves on yourself. As for this texture was did in Substance Painter using, I forgot what it was. I think it was the Japanese peacock embroidered substance source texture. I threw this on and adjusted the height so it wasn't so, like, the height was ridiculously strong for this texture, so I turned it down a bit in Substance Painter. But it's I'm starting to really love Substance Painter. Like, with Houdini, this workflow is amazing. Ate me. Am I pronouncing this right? Hello. Sanyu Frances. Looking great. Awesome. Yeah, I know. This turned out really nice. And it's not too hard to create. I'm going to show you how to create this vest today, so we can all do this. One of the things I really wanted to emphasize today is that this... Oh, I should show you this in the UVs. This... I should show you this in Houdini, though, not using Blender, which is something I was really excited about. So this is my notes. This is my cheat sheet notes. Let's make this. This is with the stitch lines. The one I want to show you without the stitch lines. Oh, I moved the file over, didn't I? Oh well, okay. Anyways. Okay, 5. So you can see, I guess it would help if we had both. So we can see this is one piece. Oh, it would help if I actually visualize the UVs. This is one piece. And to have this as one UV, one whole UV, seamless UV island, is very handy because there's no disconnect right here. Because usually when we use Vellum drapes, we have patches of clothing and the drape kind of stitches it together. That's what it does, which I'm going to show you today in more detail. But I just briefly go over this. when we're doing, now I'm going to show you the one with stitches, with separate patches. So you can see this one has multiple islands for that same piece of vest clothing. And then when we throw on UVs, they don't align. So the UVs don't align here. And what that results in, and I'll show you what happens when you put your texture on. Just give me 1 second. I need to see the name. This one is the welded, unwelded. This one. Okay, that's the middle one. Let's focus on that one. Turn on. Now there's the horizontal lines. You can see that the lines don't line up. Now this is the same geometry that I showed you in Houdini. The one with, let me see if I can put it side by side. The one with multiple islands like this results in when you throw on a texture with an image, you're going to get this disconnect here because it's disconnecting. Just like in Tommy here, these squares are not aligning, and that's what you're going to see in your texture when you go to Painter or whatever program that you texture with. You're going to see this disconnect. And what I love about Substance Painter is that when I put the Bubblepins logo on here, it was seamless. So Painter is able to place the decals perfectly, whether it's multiple UVs or not, which was amazing. So the logo is not disconnected, only the shirt. So what other stitch lines? Okay, let's try this one. This one looked really nice with the peacock. There are other ones stitched. This is just a leather one. I just wanted to test the logo, how it would stamp on. This looked pretty well. I love how Painter kept these tiny details. So it's the details of the decal from my logo is blending well with the leather, which is the base material. So it looks like it's infused into the leather, which is very, really nice. But you're not going to see too much. You won't be able to tell that much from far away, but it's those little details that you really appreciate. Can you show how you did that in Substance? I will in a different stream. So I'm going to be starting like a mini series sort of thing, so where I can showcase all my fancy work and all the work that I've working on that is not ready for like experimental stuff and test scenes and stuff like this, or substance stuff. So that will be coming soon in another mini series. I just don't want to deviate too far off from the Houdini tutorial that was planned, because my streams are so long. They end up being so long if I deviate too much. Yeah, so wait for that. That will come. The Substance one will come in hopefully sometime this week, because those will be more casual live streams. I won't have to prep as much, and yeah, that'll save me a long time. That's just something I can just do right off, like impulsively. I don't have to prepare, practice, and plan it out and all this stuff. Are you using Cycles X? I have no idea. I don't know. This is Blender. This is the LTS. Blender 2.83 LTS. I don't know if that has Cycles X. I know that there's been some huge improvements in the Cycles engine, but I wasn't sure I wasn't sure what Cycles X was. I did read about it in a blog, but I don't know. Let's see. Oh, yeah. So, okay, I think we can officially start. I'll just go over some of the things here. So all the assets will be available for Perk 1, Perk 2 members, just because the geometry is made in Houdini and it's textured in Substance Painter, which gives me the rights to share my textures, which is awesome. Because I think a lot of you will like Seamless Peacock. This one looked amazing. I wonder how it would look on Tommy. Okay, well, I'll append him later. I forgot where I put his geometry file. I'll add him in later. Let's see how he looks with this vest. So I can share the texture image files, like the PNG, JPEG files. Right, the mini series where that's gonna come up soon. Mini series on a live pop-up stream. It's a pop-up stream just because I haven't figured a time slot where I'm planning to have this daily. Well, somewhat daily-ish. There will be exceptions when I have appointments or when I have official tutorial live streams, like ones like these, then I would pause on the pop-up live streams. So it will be daily-ish and it will be casual, but it gives you an opportunity to ask any questions, so I can do them live to the best of my ability. All right, so let's start. Oh, let me check the chat actually. Cycles X is in Blender 3. Oh, the alpha one. Is that an alpha? Let me see. I get distracted easily. Is that the alpha one or the beta one? I think the official release is 2.9. Yeah, 2.92. That's the official release. So that's the bit. No, I usually stick with the official releases. I don't use the alpha or the betas that much unless they have a very interesting feature that I'm really interested in. Then I'd give it a try. Because it crashes quite a bit. And I don't know how to fix the scenes in Blender as much as in Houdini I can fix them, but in Blender I don't know it as well. Not that great. No, it doesn't have Cycles X. But it's really amazing. Yeah, it is. It's really fast. Cycles. It looks a lot better than Eevee, but Eevee's so much faster. But this is a very light scene file, just a jacket with like one set of materials. So I decided to splurge on the CPU cycles. So brief discussion how I'm just gonna start the tutorial. Brief discussion how seamless and stitched lines UVs. Right. So I'm going to show you two ways in doing this vest. The first way, I'm going to drag over that scene file again. So just to show you, this is the one with multiple. So this is the same vest. Let me get rid of Tommy. This is the same vest, but it has multiple UV islands. So this is split into, like you can see the disconnect here. So if I were to put the Japanese embroidered, that peacock thing, or is it this peacock thing here, you would see like, oh, not this one. One second. Stitches this one. This, you would see, this is the welded one. This is coming up soon. Okay, this one. You would see a disconnect like this if I were to throw a texture in, just because these are two different UV islands. So that's the disadvantage of having the UV, creating your UVs like this. And I'll show you how this was created. So this is created the old-fashioned way. this. So you have this. So we're going to apply a Vellum Drape node on this, and we're going to put seams here, and it's going to stitch. The Vellum Drape node will automatically stitch these lines together and create sew these lines together and create the jacket or the vest. Now, if you just simply throw on a UV project like this, so I'm just going to do a quick shade. Or I thought I would do a quick shade. Let's see. Labs, visualize UVs. Whoa, where are my UVs? Give me 1 second. I think it's not updating. Let me restart the scene view. Project. Let me see what the UVs look like. Ooh, where are they? Oh, there they are. Okay. Okay, there's my UVs. So we just throw on a UV project right after we create the patches, right after we create the clothing patches like this. You just simply project the UVs in an orthographic view. You're just going to get this, which creates a disconnect on the hip or this side spot here. It doesn't continue. It's not seamless. And that's the disadvantage of doing it like this. It's easy just to throw it in like this. But if we take this a little bit further, and this is where I try to mimic like real clothing, when people actually do sewings and they're cutting out the layout for the clothing. This is what they try to do to preserve the entire cloth. Just give me here. Now, this is what we had before. So this is what we had before. Back and front. Then I take, okay, I'm going to template this. And then I take the front part of this clothing patch and I turn it around. Well, I split it into two first for the zipper line. So that's what this is doing. I get that little zipper space. Then I turn it around. So it's rotated like this. Hopefully you're starting to see what I'm trying to do. Then this becomes one piece. It mimics like one piece of cloth. When I have all that, I can give it my template. I throw on the UV. Hopefully it works. Hopefully it works. I think I have a caching issue. Okay, that worked. When you throw in your UV like this, it makes this whole piece seamless. Well, at least this part and this part. And that's an advantage when you have a texture with like an image, like the one that I showed you with the Japanese peacock. Seamless peacock, this one. Oh, wrong geometry. So this is what happened. This is the stitched one. This is the wrong geometry. This is the seamless one. Select this. Okay. Peacock render. Here we go. So now you get that seamless picture. The seamless picture. And it makes it look really nice. As opposed to right here. Oop, too close. Okay, you can see that there's a line here separating the two cloth patches, which is this thing, which is these two, because they're not going to align. And there's all sorts of other issues too, like this stuff. Okay, let's see. Stitches. No, welded. This is the wrong one. Stitches. This one. Did I select the wrong geometry? Oh. Stitches. Well, this one. Okay, this. There you go. So you can see that it's disconnected. Except for the logo. Because the logo was painted on using Painter, and Painter's awesome, that's why. Okay, so that was that. So that's one of the advantages I want to show you, having, like, why go through all that trouble rotating this guy over just to get that seamless UVs. Because not all pieces of clothing, if you go out and buy a jacket, you're going to see that it's patched up. It has sewing lines in this area. A lot of them do. Not all of them, but a lot of them do. And if we were to mimic that, if we were trying to create a scene with the jacket and we wanted to be realistic, we would want that as well, right? But it does have advantages and disadvantages. That's what I'm trying to show you. Now, that's the disadvantage that I'm pointing out, is that your image file will get that disconnect. Now, there is an advantage to all this though. Just give me 1 second. I have to load up the other file. I have to close this one, otherwise my computer will crash. So the advantage of having multiple UV islands is that you can actually add stitch lines. So these are like, some of them are hand painted stitch lines. So this is really nice here. So you see that red thing? It's a little wobbly because I'm not very good at painting. That's manually painted. So you can paint the stitch lines onto the multiple UV islands. This makes it, like, all you have to do is trace the edge of the UV island and you can get nice results like that. It's much easier to paint it this way. I mean, you can still use the seamless UV vest and still paint the stitch lines on if you really wanted it. It's just a little harder because you won't have the UV island to trace around. Oh, relax. Oh, hello. How do you use Blender? I mean, with all this, with all this, you can do in Houdini as well. Yes, you can. You can. It's just a little faster in Blender because Cycles is really fast. Redshift is really fast too, but I don't have Redshift anymore. Like, I used to use Redshift with Houdini, and I know Redshift 3 has some really nice updates, but I don't have that anymore. Like, Blender's free, so you're rich. I mean, I'm gonna have a Blender tutorial. Again, I'm gonna be introducing a new mini series where I'm gonna have like live pop-ups. So it may be a live pop-up for like, I don't know, half an hour a day maybe. Well, it won't be every day. It will have every day, daily-ish, with exceptions. Sometimes it gets really busy. So and that's when I can squeeze in some Blender tips here and there. And that's where during the live pop-ups, I can talk about random things, like how the workflow between Houdini to Substance. Yeah, you can ask. That's a chance for you to ask questions, showcase some of the stuff I'm working on. And yeah, that's coming soon. Rich, thanks for doing all these. Oh, thank you for watching. I won't be here if you guys weren't here, so it's all thanks to you guys. Dead pianist. Oh, because Blender is easy and faster. Yes, that is true. What if you tear it? It will still maintain the UVs. Oh, that is a very good question. That's coming up soon. Just hold up on that. I haven't talked about vellum tearing yet. That's not going to be covered that's not today, but maybe soon in the future. But there is something related to that I wanted to talk about, is welding what happens when you weld the cloth patches together, because okay, I will get into that. Just hold that question for a second. Sanyu, will stitch lines work on the seamless UVs? Yeah, because those were hand painted, so it'll still work. It's just easier to trace around the UV islands. So like, so I would like put my tablet and just draw. I would draw here for the sleeves, because that one has sleeves. We're not doing sleeves today because that's too much. Right here, like I could just trace here and just trace it down here. It's just so much easier that way. But if you're really good at painting, that's not gonna stop you. Like that won't matter for you. I'm not very good at painting. Oh, RPX, you can use cycles in Houdini maybe too. I mean, for sure you can use cycles in Cinema 4D. That's cool. I don't know how to use cycles in Houdini. I wish I wish they had more like tools. I've been meaning to work on a tool to bridge the workflow gap between Houdini and Blender. But I don't know enough of Blender scripting to create that tool. So maybe one day soon. Hey, I just joined. It's 9:45 here from Kenya. Awesome. Welcome. Matinda. I'm so sorry if I mispronounced the name. Okay, let's go back. Okay. So where was I? Okay, seamless UV can handle images very well, right? So we covered that. Clothing patches can be useful, right? The stitch lines, as I said, you can trace the stitch lines. Trace the UV islands. Painted stitches. Okay. Oh, the welded question. So going back to that welded, someone had asked, what if you tear it? Sorry, not this one. Where is it? Somewhere around. Oh, what if you tear it right here? Will it still maintain the UVs? Now there is vellum tearing. I'm not going to cover that today, but there is something related to that I wanted to talk about. Just going to bring this over. So you have your clothing patch like this. You have your UVs created, and then you have your vellum here. Fancy. Hopefully my cache works. Oh, good. Okay, so the cache is right here. Now, this cache, it's before the vellum post-process. Once you put the vellum post-process gives you an option to apply welds. Now, what does that mean? So this is the drape node. You run this node and it runs the solver, and it calculates how you it sews it in for you. And then I cache that out over here. But what I wanted to show you is that these seams, so this is a seam line here. They're not together. They're not welded together. They're not one piece. So you can see that's just going to rip apart right there. And that's why Houdini gave us a vellum post-process node where you can apply welds. But once you apply the welds, I find that it messes up the UVs. Oh, 5. Okay. So this is before applying the welds. Right here, before we apply the welds. Watch what happens when I check this button. It messes up the UVs over here because it's trying to connect this side to this side of the UV island. So you see this crisscross. Let me uncheck it, and it's nice and clean cut. And you check it, and it's trying to crisscross. So what does that look like when you put a texture on? Oh, I have to open up the... Dang it. Okay, let's see. Okay, let's see how my computer can handle all these applications. this is the welded one. Okay. Render welded. Okay, so this is what happens. You get this crisp. This is the geometry trying to make sense of the UVs. It's crisscrossing just because we applied the weld from this end of the UV island to this end of the UV island. It's not gonna end up well. Like, I don't know why it does this. But that's what happens. But if you were to put it into like a simulation, you would have to apply the welds. Otherwise, it would just, you know, rip apart. Okay, I'm going to close all my Blender applications. This is my notes. Just going to take a look at the chat one more time. Cycles number 1. Valesfa. So sorry if I pronounced that incorrectly. RBXLX. There was a Houdini engine in Cinema 4D, so you can wrap some HDA in Houdini and use it as Cinema 4D. Really cool. It is. I think the Houdini HDAs work with a multiple number of different programs, like Epic Games, Unreal Engine. Blender, I haven't heard of anything yet. I hope one day. Or maybe we can write our own. That's what I'm thinking. Just because Houdini SideFX has given us the power, like a lot of scripting power. I don't know if it's powerful enough to write our own little bridge between the two applications, but you never know. Do you have to stitch it, or maybe you can model the jacket as one piece? Yeah, that's what I've been saying. You can model it as one piece. That's this one. To mimic real life clothing, to put it in one piece. Okay, so without further ado, pan painted this, we did that. Shoulders. Oh, that is one thing. I closed the application. The shoulders are not seamless as I thought, as I originally depicted in the teaser video. So that's something I wanted to clear up. Okay, I'm just gonna make it. Is it this one? Yeah, so here I'm depicting that it's seamless. Here, where are you? This. It's not exactly seamless here. It just looked like it was seamless, so I thought it was. Over here on the top, here is not seamless with this. But it doesn't look too bad with the textures. Let me just open that one more time. I think the peacock one is the best to show you. Seamless. Okay, that's this one. Peacock. Let's render it. There is a bit of disconnect. I hope you can see this. This little blurry thing here. That's the shoulders. So it's not exactly seamless. It comes really apparent when you have like that horizontal strips. Is that this? No. Seamless horizontal. Not this one. That is 90 degrees. So I turned this thing in 90 degrees. So it's, instead of stripes going left to right, it's going up to down, which works nicely for the entire piece except for the shoulders. So that's when you really can tell that there's a disconnect on the shoulders. Okay, I'm going to close this guy. Wait. Check the chat one more time. Just give me a second. Give me, just get a glass of water. Oh, for that? Oh yeah, no problem. No problem. You can join in anytime, no problem. Tweak the Vellum solver to behave like real cloth. Or maybe heavy fabric. For the heavy fabric, I believe you can mimic that using the stiffness attribute. That would probably be your best chance. And thickness, there's a thickness and there's a density and there's a mass. That those parameters are your best friend when you're trying to do different types of fabric made of different materials. But you have to tweak the Vellum solver to behave like real clothing. Yeah, there's many different parameters we can use. In order to solve the UV issue, like, here's one of the techniques that I'm using that I'm going to show you today. So take a look at what I do and see if it works for you. Okay, so let's begin with the vest. Now I'm gonna bring in Tommy. Sorry. In order to bring in Tommy, you cannot use the object merge. It won't work. Just because this is a mocap I grabbed from the characters tool, shelf tool over here, this guy over here. So that's based on an older type of rig that SideFX has set up using the old way of doing the bones. You can't simply use the object merge to bring Tommy into this context. What I do is I use an agent. Now I don't know if this was meant for that, but it works for me. The agent is meant for the crowd systems, but it works good enough to bring in Tommy into this context. Now, once you use the agent to bring him in, you're gonna lose all the textures. That's because this agent node is part of the crowd system. It packs it all into one point. So this is all packed geometry. We have to unpack up. So agent unpack. And we get everything back. Okay. Oh, let me save this. Okay, now we're going to create a vest for Tommy. Now, I do this very differently from how some of the examples that SideFX shows. If you've ever watched some of the Vellum tutorials or master classes or looked at some of the HIF files from SideFX's tutorial list, they usually use a draw curve and they draw it out. So they draw the shape of the vest or clothing, something like that. That's terrible, but you get what I mean. Like, you draw it out so you have that shape and you slowly work with that to create into a clothing patch. Or you can use the curve, which is probably easier to control. Like this, click, 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 click. And I think I'll close it for you. Oh, what did I do? Okay, yeah, close it for me. There you go. It'll close it for you when you check this button. So that's not what I'm going to do, just because I'm not very good at drawing. So I try to avoid it. What I'm going to do is I'm going to use a box. Now, some of the stuff I'm going to grab from my other screen just because it has the dimensions already created, so I don't have to tweak it too badly. So I created a box. Actually, I can show you that live. I don't know. Just drop down a box. Put the render flag here. Template your character so you can actually see it. Select this box. Come over here and press enter. And we can fiddle around with this. We can like make it into the shape. Like, you can see what I'm trying to do. Make it into the shape. So we got a somewhat shape like this. Now I'm not going to use this one. I'm going to use this one because I did this with more time and more care earlier. Now I'm going to turn this into... This is a different way of doing it. It is different. Let's just say it is different. Yeah, I'm gonna have to like change this up a bit. And what I need to do is that I need to scale this a bit, because the only faces that I'm going to be using out of this box is the front and the back. So this one over here and this one over here. I'm not going to be like everything in the middle. All these faces in the middle will be deleted. Therefore, the front and back faces are way too far. So I'm going to scale it inwards. Now, I only need to scale the Z. So what you can do here, you can do it like this, using the parameters here, or you can do it with like eyeballing it here, using the GUI widget. Select this, mouse over the viewport, press enter, and you'll see this widget. Then press E. E will get you the scaling, or you can just use the mouse, the buttons here, which is rotate, this one, E here, scale. So I just want to scale it inwards. Something like that. Okay. The one that I used was 0.4, so let's just stick with that. Now, next thing is, I have arms here. So I'm going to cut an armhole over here. So it has that nice curve that comes down like this. The way I do it is very different from your usual curve drawing workflow. I use a boolean. And now I'm just going to copy and paste the tube over. So this really, all this is just a tube. Really big tube. On the z-axis, a polygon with end caps. Turn it down just because it's so huge. Transform. Well, this transform is just moving it into position. Oh, this is the neckline. Sorry. This is before the curve in here. So here I'm trying to cut out the neckline. So we have our vest here. And you can, if you've seen... I closed that. Darn. This is the finished one. If you've seen it over... Oh. There's a neckline here that's circular curved in, and that's how you have that's how clothing has for the neck. So that's what I'm trying to accomplish with the tube and the boolean. Stick the boolean here, and it's subtracting my box, subtract the tube. This is the workflow that I am more comfortable with because I like working with primitives and geometry shapes rather than trying to draw it by hand using a curve or whatever. So by leaving the box as a 3D geometry object, I can manipulate this box and the shape of it using the handy and very fast performing Boolean node until I get into a shape that I'm satisfied with. Then that's when I delete all the primitives in the middle, and then I'll have my patches. Okay, so now that we have the neckline, let's cut out some arms. Okay, I'm going to use the same tube. Well, not the same tube. I'm going to use a tube. So this is way too big. Now I'm just going to paste the ones in. I'm not going to do this part live just because this is very tedious. I don't know if you want to watch me trying to resize a tube. So this is the tube that I'm trying to resize, and look where it's positioned. It's positioned right right at the arm. Here, right on the arm right here. So I'm just gonna cut out some armholes. And again, using the same Boolean subtract trick. There we go. I find this much easier to handle, this workflow. Okay, now I start grouping them. Now what do I need to group? Because I need to know what to delete. I only want to keep the front and the back. I don't care about the stuff in the middle. So I want to keep the proceduralism. I mean, what you can do simply, okay, let me actually show you. Here, I'm gonna take, select your Boolean, the last node, whatever. Come here, select a cursor, select a primitive. So I'm gonna select this front and this back. While the mouse is still hovering over the 3D viewport, hit tab. Then you can go blast. Now it's blasting the other ones just because we need to toggle this option, delete from non-selected. So we want to isolate our selection. And then voila. We have our patches. The patch shape, sorry. It's not a clothing patch yet. You can do it this way. So this is the manual way of selecting the pieces. What I prefer is to use groups. And what I do, this is the long way. But this way, in the future, if you change something enough, it will still keep some of it, and you won't have to keep reselecting stuff. So that's handy. I'm gonna group the front and the back. So this is on the z-axis, if I remember correctly. Where's my grid? Well, anyways, it is the z-axis. So z is this way and x is that way. Should be. Okay, yeah. So anything, this group, you can select faces based on their primitives. So let's take a look at the primitives. Now I only care about this front primitive, and the primitive normal is facing this way, which is the positive z-axis. So I'm hitting one, putting 1 into keep my normals, enable, in the group, 1. It's because we're facing this way. And spread angle just means, you know, what a range of angles from this direction. So if I increase this, look what happens in the viewport. It's going to select everything, which is not great. not for our purposes. So I want a spread angle of 0 because I know it's exactly straight. So this will be my front. I'm going to do the same thing for the back. Uncheck this. I want keep my normals. Check this. I want this -1. Spread angle for 0. So this becomes the back over here. Now, when I put a blast, I can just choose the group. Delete, isolate, delete, non-selected. So I just want to isolate the back and front. Now we're going to split it. Because I'm going to do something funky. Well, we need zipper lines on the front side. Okay. Just let me get a glass of water. Just gonna check the chat. I tried to do tearing thing with animated bake UVs and applying it to the tearing cloth as UV image sequence, but it works like 50-50. Animated baked UVs. Applying it to the tearing. It should work unless your UVs are moving. I have done tearing before, but it should be keeping the UVs as is, unless your geometry is not one piece of cloth. It's not flat. It's not a grid. Like, unless you actually gave it depth. I don't know if you watched the previous live stream when we had the belt. So the belt was actually made using the sweep node, and the sweep node was made up using these rectangles aligned together, and they were skinned like that, so it actually had depth, like geometry depth. Vellum solver works best with flat primitives like grids, and then because the Vellum solver actually has a thickness parameter, so I'm suspecting that may be messing up your scene. I'm not sure, not 100% sure, but that's something we can explore in the future. You can't bake UV, you can bake the texture on the UVs. Well, UVs are actually just, they're stored in like when you project the UVs, they're going to be stored here in as part of your geometry. So I guess that's sort of baking. I don't know. It's stored. It's just not stored as part of an image. It's stored in there somewhere. Look alike. There are workarounds to do that procedurally. I actually don't know where the conversation has came from, but Matindi. I think I prefer this new method. Oh, me too. This box method is so much easier. It's for people that can't. Well, no, it's much easier because it's with stuff that we're familiar with. If you're very comfortable with procedural modeling, I think this is for you. This workflow using boxes. Using boxes instead of the curve node, because I'm not very comfortable with painting or drawing. This method is so much better for me. Okay, let's work on that zipper line. Now, this guy here, we can. Now I need a zipper line here, just because I'm gonna put a zipper here. I need to punch a hole in. So let's drop down. Well, I know I need a boolean. And I'm going to draw my box. I'm going to get my box in. I'm going to put him over here. Then I need to drag him over. Need more space. So what we're going to do is we're going to take this geometry over here and we're going to subtract this box. But the box is not in the correct position yet. So let's do this. The one way you can do it is, again, manually. So let's do the box. No, that just takes out everything. Don't worry. Just give me a second. Here. Let me zoom in. So you can like eyeball it like this. And you're done. So you can just do it like this. Now, I prefer to try and make this procedural because every single time I'm going to change this, my clothing patch size. For example, if I make this guy over here any larger, I don't know. If I make this larger, yeah, I'll just put it in. Template that, so I make it larger here. Now that's not gonna work out great. Look, it's not cutting in the right position. If I make a change here, then I have to update this box as well. So I have to come over here to this box and really update it. And that's every single time I make a change over here. And that's going to start to add up. If you keep on doing things manually like that, every single time you make a change at the beginning, you're going to have to go through the entire entire network and sort of figure out which one was manual changes, which one was procedural. Try to go as procedural as possible. That will make your life a lot easier when you reuse your network to recreate something different. The same, I don't know, vest, like what I was doing, a vest with sleeves, or a different kind of vest, or a vest for a different character maybe. So then you can reuse your work and you won't have to redo everything. So you can do it manually, and it is faster. It's a lot faster. You just eyeball it. Oh, let me take out this. So we're not going to do it like that though. What I will do is that I'm going to take this original shape, and I know I need the height of this. I need the box to be the height of this guy. But the problem is, now that's one thing you need to know about the box. The box has an input. Whatever you input in here, it will be the size, it will be the bounding box size that this box will get. For example, if I put a rubber toy here and I stick it into the box, I'm going to have a box of the size of the rubber toy. Let's take out... Okay, let's take out the template for this guy. Now you see, this box is exactly the height and width and length of the rubber toy. It's a bounding box. So the box gets the bounding box dimensions of the rubber toy or whatever is inputted in here, and we can use that. That's because I need the height. I need the height of this of the front piece. But if I just stick it in, I'm going to get a flat surface just because this the front piece is flat. It's just a grid because we had blasted the middle pieces. We blasted all these primitives, these faces out. So I'm stuck with a the front piece being a flat grid, and when I feed it into the box, I'm only gonna get the height, but I want the width and a bit of width at least. So I'm gonna make it a little thicker. I'm gonna add a poly extrude. Now, poly extruding this piece of cloth is not changing anything. We're not using this. We're only using this to create a cutter for the zipper line in the middle. Okay, I'm just gonna output the back as well. So poly extrude a little bit, and remember to check the output back. Let me put the template back on the character. Now we have a box, but we need, there we go. We need it like this. We need it in the middle right here. So that's not, sorry, just looking at my notes. So now we can scale the box. And we can scale it. Let me hook this up first so you can see it live with the character. Scale it here. Oh, I keep forgetting that. There you go. So I just want to show you. So that's where your cloth is. Our box is right here. That's the box. Scaling it. Like here, okay, the exact values that I used was 0.025. Very thin to get that. So whenever we actually change this, come back up here and I change this, that's right here. So that's where, if I change the size of this guy, hopefully, I'll see this update. Let's give it a try. Okay, yeah, see, I'm increasing the size and the zipper line is keeping its position. Okay, let's see. So now we have a zipper line. Now it is complaining just because this here is treat as a solid, but it's not a solid. This here is a grid. So we need to say surface. It'll get rid of that warning. Okay, so that's our zipper line. Sorry, that was a mouthful. This new method, okay. All right. Now let's start merging this back. The front and the back. There's actually more stuff we need to do, but let me start to put it together so you can see it. So there's our front and back. Now we cannot just feed this into the Vellum's drape because there's no topology. There literally is nothing in there. It's 56 points. But look at this. Oh, let me... Okay, hopefully you can see those points. There's no topology in the middle. It's a single polygon piece. This is not going to go well with the Vellum at all. So there's something in Houdini, the planar patch, or planar patch from curves. Planar patch gives you a patch of cloth, a grid, with nice topology that works well with Vellum right off the bat. but it doesn't have an input. So this is simply just a grid with nice topology. Now that's not going to work well for us because we already have our shape. We already have the shape of the vest already made. So we can use this one, the planar patch from curves. Now let's drop that down. This requires curves. So if we just connect it like this, it's not going to sit well. It's not going to understand anything. Well, for one thing, I find that this node, you need to feed in one patch of clothing at a time. So we have three pieces of clothing patches. We need to have it fed into it one at a time. Not only that, okay, let's try doing the back, just because that's one piece. Let's start with that first. Okay, let's go there. Now let's resample, reverse curves, or no, resample the curves. You want to resample the curves just because this is not enough topology. Resample the curves will give you a bit more topology so you can keep this shape. Now let's click this. Now this turns, we need to also increase the interior edge length. Let's go, I don't know, 0.02 is the one that I used. So now we have nice topology. Now that's one way of doing it. But as you can see, the normals are reversed. This is what it looked before. Nice shiny white facing this way. Once we put this in, comes over here. So the normals are reversed. Now what you can do is you can reverse it. Yes, you can do that. Reverse it, flip it all the way back. What I prefer is that I convert this because I want to keep this shape. So I'm going to convert this into lines. Then apply the planar patch. Now it doesn't fix the reverse. It's still reverse normals. I like doing it this way. Well, one thing, it was in the SideFX tutorial example. That's how they did it. They always converted it into a line and then fed it into the planar patch from curves. And it worked well like that. And I got used to using it. Otherwise, can you see that? It changes the shape a bit. If you don't convert it, if you don't convert this shape into lines and you just feed it into the planar patch as is to get the vellum topology, it's going to change its shape a bit. No matter how hard, like you can always keep pumping this down and get more higher resolution. Or you can just convert it into lines. Now you still need the reverse though. You still need to reverse the normals to get that. And I'm going to do the same thing on the other side as well. So let's go over here and let's do it on the front. Convert line. Now, if I remember correctly, these two curve patches, I believe we have to feed it in separately. If I remember correctly, let's give it a try. Planar patch from curves. Let's feed it in. Well, it looks like it works. Okay. I thought you had to feed it in separately, like with the for loop and all. I guess not. Okay, so I want to keep the same planar patch resolution. So I'm going to come over here and I'm going to copy this value. And I'm going to paste it in here as a relative path. So it's going to be the same same resolution. And remember to check the resample curves, because you're going to get this nasty topology right here. If you don't do that, you need to check this. Okay. We're almost there. We're almost into the fun part. We're almost there. I think I lost a few people along the way though. Let's see. Okay, so I have it merged. Now, there's one thing you need to know about the planar patch. It adds this material UV. This material UV causes me a lot of headache. But not for this one. For the one with the seamless UVs. When I'm trying to do the seamless UVs, this material UV gets in the way. So I did a bit of searching. Apparently this material UV behaves exactly the same thing as your UVs. Like when you put down a UV project, you're going to get UVs. And they're placed over here in the vertices here. It's the same thing, except the material UV is for the Vellum solver to understand. The Vellum solver is the only one that understands it apparently. Or in this case, in this situation. I don't know what other use case is the material UV has. So, however, the Vellum solver doesn't necessarily need that to function. I actually just remove it. For the stitch ones, the ones with, this is only a problem if you want to do the seamless UVs. For this, it's not that much of an issue. If I just throw down a UV project like this, it's not going to cause me a headache. It'll still work. Now, visualize UVs. Remember to turn this down. This is like 1010. I just want it 1-1. 1-1. Initialize. Oh. Okay. You also, so UV project. Huh? Okay, let me do this. Let me do it this way. Initialize. Okay, there we go. XY plane. This moves it over. See, this is what I mean. This UV project creates UVs over here, and then when you try to visualize the UV over here, it moves it over there. And that was confusing the crap out of me. It was driving me nuts. And then I realized you can actually view the material UV and the UV. So they're actually different. You can leave it in there. What I preferred, because it was giving me a lot of frustration, I just removed it. Material UV. So I'm just going to delete that. That way, we only have one set of UVs then. It's just the UV. Okay, now we can start feeding it into the Vellum solver. So this is the funner part. Now let me just check the chat. Okay. Now, what's the first thing we need to do? We are trying to convert these, this geometry into a cloth. So we need the Vellum cloth. So Vellum Luckily, they SideFX create a Vellum configure cloth, which is nice and already made for us. So we can just drop it down. This just has some basic constraints that is with the parameter values targeted in being a cloth, which is very handy. So we don't have to like drop down a Vellum constraint node, because this is just a Vellum constraint node configured to a cloth type. Now this is not going to do anything. This just creates the Vellum properties for us. What we need to do is create a Vellum Drape. That's where all this stitching happens. Just give it a second. Okay, the Vellum Drape is where we stitch things, where this actually becomes a cloth. Now I'm just going to grab my Tommy character over here and I'm going to drag it over because I'll need it now. So I'm going to hook this guy to here, the third input, which is the collisions, because I want the cloth to collide with Tommy. I don't want the cloth to go right through him. So we're going to hook it up like that. Come to the drape. Awesome. Now we have to define the seam lines. Where are the seam lines? What are we sewing together? That is what the Vellum Drape is asking us. So come over here to the Vellum Drape. Come to the draping, a draping tab here, and click this weld additional seams. All right. Now we have to add seams. Okay. Now, how do we actually weld seams? You pick the points in order, and the points will line up with, you're going to pick two set of points, group 1 and group 2. Now, the first set of points, the order matters. So, say, for instance, I'm gonna just show you first. Let's do the shoulders, because that's just 4 points. Now, I want this one. Left click that. Hold down shift. Left click that. I'm still holding down shift. Click, click. Then press enter. Now that's in order. So let me pick my second set of points, which is the where I'm going to sew to, which is the opposite side of this. So click, shift, click. It's still holding shift, click, and click, and then enter. And look at it, lines up nicely. Now, for instance, if I didn't click it in order, what will happen? This is important. So I'm just gonna remove this point. To remove a point, hold down Control on your keyboard, and then you'll see a red. And if you look carefully, my mouse cursor is starting to go turn. There's a minus sign right next to the mouse cursor. It's really tiny. But anyways, the point turns red, so you'll know. Remove this, and I'm going to change the order. I'm going to select this one. So shift, left click, and I want to see what happens. The last 2 points crisscross. So the order that you choose the points is very, very, very important. So let me undo all this. Oop. Okay, this is good. This is what I need to keep. Now the second tip that you need to know is, let's create another seam. So come here and create press this plus sign here for another set of new points. Let's click this. Oops. No. Alt. There we go. Now this, I want to sew this side to this, to this side. This is a lot of points. Now, if I click, I'm going to get tired really quickly. So, select your first point, hold down A, as in A, B, C, D, A. Hold down A, hover your mouse over another point, and look at it. It's going to identify the edge loop, the connecting edge points in between the one that you're hovering and the first one that you click. This is a huge time saver. When you find the point that you want, like you can even go like here, but I want this. find the point that you want, left click it. Okay, then release the key on your keyboard. And look, you have your seam right there. This is a huge time saver. And don't forget to press enter. So let's do it for the back. Remember, the order matters. So up, top to bottom. Sorry. Select the first one, hold down A, hover, select the last one. There you go. Enter. Nice. Nice and quick, eh? Okay, let's do another one because we need the other side. This one, A down. See, I'm starting from the back side. So the back and front doesn't really matter. I mean, your sewing points. Why would it matter sewing the back from the front? I guess it would if you use the sewing machine. I don't know. But in the software, it doesn't matter. Back and front. The only thing it matters is the point order. Awesome. We are done. See, the vest is nice and simple. Now, how do I actually sew this now? This vellum drape actually has a vellum solver within it. It's actually a solver inside of it. In order to actually activate the whole simulation, just run it. Run the simulation. You can see it sew together. Now, right off the bat, I'm identifying a few problems. The first problem is that this part is flying off to the back. This part is flying off to the back. The front piece is here. If you've seen this is my finished one. My jacket is staying straight because it's this is the shape that I want. I don't want the back, the front clothing patches to float to the back. I want to keep the shape of the jacket like this, or the vest. And there's a way to do this. But what we need to do is we need an extra piece of geometry that will relay it, that we're going to project it onto Tommy. So that we're going to tell the vellum drape, okay, I want this edge here to stay as close as possible to Tommy's, to constrain to Tommy's body. And we can do that by projecting some primitives or some sort of geometry onto Tommy and then feeding it into the vellum solver and go like, hey, I want you to stay here, sort of thing. Okay, so let's do that. Okay. I'm just going to pull this down because I need... okay. You know what? I'll just do it like this. We need this patches. So let's go back to this patches. Let's bring it over here. And I'm going to put this down. And this is my patches. Now, I really hate seeing this crisscross here. I don't know why. I don't like crisscrossing stuff like so far apart. There is another way around it. You can drop down an object merge. Connect it here. And what you do with the object merge, point it to this over here. Point it to this node. So just Control C. Come over here and just paste it in. And we get it right here. So we've brought that over rather than just crisscrossing it over into this object. Okay. Now, what do we want here? I want this edge is what I'm concerned about. So let's select that edge first. Group edges. Now I'm going to manually select this just because I haven't found a way to nicely procedurally select that seam line or this edge line. So let's just stick with this is the part where I turn manually, turn to the manual stuff. Select this first edge. Now hold down A to get the whole seam line all the way down. And then select the last one. So the A trick works for edges as well. Press enter. Okay, I'm gonna call it stitch line. Now I'm gonna blast that edge because I want to isolate it. Edges isolate. So I want that edge line. Okay. Oh, sorry, I skipped a step. Sorry, this is like previewing into the future. Sorry, skipped a step. So we have our patches here, and I'm trying to take this edge or these points, and I'm trying to project it back onto Tommy. So let's do that one more time. Let me drop down a group. And I'm gonna, instead of taking the edges, I want the points. And I'm just gonna call this stitch line as well. Stitch line. And I'm gonna select that again. But this time it's points. So I'm gonna get that. Now I'm gonna I actually need the primitives. So I'm gonna promote it. Because it's just that it's really hard to select the primitives over like that. This is a very convoluted way to select that edge. Stitch from points to primitives. Okay, so then I have the primitives over there. Alright, and then I'm going to blast it. Because I'm going to isolate it. Stitch. Isolate that. So we have this. Now I want to project this onto Tommy. Okay. I'm going to use that same trick I had before. I need this over down here, but I don't want to crisscross again, so I'm going to use the object merge. Copy this node. Come onto the object merge. Paste it. Oops. Paste it in here. Into this object. Okay, so we have Tommy here. So what I'm going to do is use... Houdini has a node called ray. And what that does, it just projects one geometry onto another. So let me put that in first before I start yapping. Connect what you want to project. So I want to project this geometry onto Tommy over there. So this is the geometry I want to project. Where do I want to project it to? That would be the second input. Select this. Now it's not moving. Nothing's happening. Let's come over here. Project rays. We're gonna, instead of projecting direction from normal, I'm gonna specify the vector myself. And I'm gonna get rid of this, the link. I want to go and project this strip of primitive back. So that way. So that's the negative x over here. And look at this. It snaps onto Tommy right away. Now this is the geometry, the reference geometry we're going to feed into the Vellum setup. However, I'm going to show you, this is the wrong way to do it. I'm going to show you the wrong way first, like how I usually do things. Oh, let's drag this down. Now there's stuff that we need to fit in between here. There's something in Vellum called a Vellum attached to geometry. This will allow us to attach the edges of the jacket onto a different geometry so we can get, whoa. Okay. Let me try that again. I'm not sure why. This was happening yesterday at random times. It was giving me a lot of errors. That seems suspicious to me. So what I'm going to do is I'm going to take whatever I did right here and I'm going to create another geometry node. That's what I did yesterday and the error went away. Don't know why. I must have clicked the button by accident. Okay, so let's continue where we off. Vellum attach geometry. Okay, yeah, see the error goes away. I have no idea what happened. What this does, it will attach this cloth, this side. Oh, so let me just play this. Go to the vellum cloth. So you can see here, it's flying off here. I'm going to attach this side onto the geometry in the middle that we've created over here. That's what I'm trying to tell it. And that's what this vellum attached to geometry node will help us do. It will add a vellum constraint to tell the vellum drape to try to keep the cloth, this part of the cloth to this geometry. So let's hook it up first. The issue with, not the issue, one of the things that this vellum attached to geometry node needs, it needs this slot. So we can't put Tommy in here. So that's one thing. Tommy's going to get lost in this chain. So let's cut him out and let's bring him down. Now we need a bit more room, so I'm going to bring it down. Bring him all the way down. I'm going to connect it to this over here. So we'll need him later. We'll need Tommy later, but not now. Let's attach it first. That's how we connect our attaching geometry here. I'm just going to call it, I don't know, attachment. Attachment geo, how's that? And this is on the right side. So we're going to attach this onto the third input of the vellum constraints here. That's how it knows. So let's specify it first. What do you want to attach? This, because we have to actually tell that node to attach this edge. So we can actually pick it the same way we picked it before. Select. Now this is not going to work well. Let's see. Let's turn it into points, not primitives, because points is a little tricky to select. Oh. This one is A, all the way down, and enter. So we have that. Did it work? Okay, so it did work. You can see it attaching it all the way down. Now it's not great. This attachment I don't really like just because we fed our attachment geometry. Our attachment geometry here has more points than what we selected over here in the jacket. It has more points than that. If you want to attach it exactly, like you don't want to guess anything, you want it to do exactly what you want, then feed it exactly the same number of points. So that's why I tried to show you this way of doing it. But let's run it through it since we have it set up. Let's go through and see what happens. It'll still work. I'm pretty sure it'll still work. Okay, let's do this. So you can see this is attaching, it's sticking to Tommy more than this side. There's a few other things that we can change in the Vellum Drape because it is a solver. It does have parameters that we can fiddle around with. If you come over to the Vellum Drape, weld properties, there's a welding frame delay. So there's actually a delay in 10 frames before it actually starts welding or stitching it up. And let's look back. Let's go to frame 10. It's still not welded. It's close enough, but it doesn't make that connection. Same here. It's not until you go to frame 11. Yeah. So it starts to really pull it in. And there it is. So it starts attaching it. There is a 10 frame delay. Now, I don't like that. I'm going to give it, I don't know, 1. Let's give it a try. And rerun it. I think that works a lot better. Well, except for this intrusion. Let's see. I'm just taking a look at my notes to see what values I had. So I mean, usually when you're trying this out yourself, you would actually fiddle around the numbers and trying to find that sweet spot. But if you're doing a live stream like this, you don't want to see me try every single parameter. So the numbers that I used was 3 and 50. The traction stiffness. So I turned down the stiffness. I'm not sure why I turned down the stiffness. I would imagine I would want more stiffness. Let's delay it to 3. The solver is 0.5. So I turned up the time scale so that the Vellum Drape would work faster, and gave it a subset of 4, I guess, to fix this anomaly over here going through the geometry. So 4 and then 5. Oh, 500. Okay, let's give this a try. Okay. So I think that works a lot better. Now we also have to attach the other side as well. And this side is not strong enough either. So let's go back to our attachment geometry. Oh, here. Now I had just matching some of the stuff that I had. I turned down the rest scale, this, so it would squeeze a little better. But I think the main now, okay, this is something I want to show you. This here, it's attaching from here to here. Yeah, what I'd like to do is move this downwards. But that's not going to help us in this case, because this goes back to that primitive geometry that I have over here. Now, let me just show it to you, actually. So I want this geometry to attach lower. So this to sort of come down here, like to the chest over here. So it would line up better here, because this is getting attached from here to here, here to here, here to here, here to here, here to here. It's not, this needs to pull it down a little more, because we have an offset. There's a bit of space over here. I hope you can, here. See, there's a bit of space between the top and then the shoulder. So this cloth was gonna fall downwards a bit, that little offset space. So I want to pull the attachment down a little bit more to maintain its shape. I mean, this is not low enough. I want this to come down here or something. Just gonna show you what I have. Oh, actually, it's almost the same over here. I think it's the bottom. This is what I have on my side. So you can see this is being pulled downwards. The upper part actually looks pretty good over here, except for the second point. This is way too close. You want everything to be pulled down evenly. Otherwise, you're not going to get that nice cloth shape in the right position. These ones in the middle are not getting pulled downward at all. They're just snapping like up, like directly straight towards them. So I want to pull this geometry down. So let's try pulling this down. Okay, let's do this. This the geometry here. That's this primitive strip that we selected. Now let's throw a transform and just pull it down. Like that. Let's see what happens. Okay. So this is still not giving me this result. This is the results I want. I want everything to evenly. I want lines going drawn from the top downwards, top downwards, top downwards, like that. This is like, it works okay for the first one, and then kind of messes up. So that's why we can't use a primitive. If you want it to do exactly what you want, have the number of points here, that's 66, to match the exact same number of points that you select in this group up here, which is this sleeve. So this is way less points than this primitive over here. Now, how do we fix this? Now, I selected the patches here. Oops, patches here. And it's, I used a group. So this was manually selected to select the points. I wonder if I can just like take all this and ignore it. I wonder if that would work. Sorry. This, and I actually have to blast this over here. So just take these points and forget about all this fancy stuff I did here. Stitch point, stitch line here, delete. Okay, we have these points right across. Yeah, that actually works. I'll keep this, so it's pulled down. Attachment, I think that'll work. So we don't actually need primitives. Here, I'm gonna, so this is fine. Primitives here, turn it to points. Now what we want to do here, you can just put an asterisk if you want, but you remember the order matters. The asterisk may not always work. Oh, so it does need primitives. Let me select this one more time. This to A. It's not getting that. It's not getting that attachment. Let me remove the constraint to closest point. Okay, so yeah, the asterisk won't work. This selects everything in this attachment, the third input over here. Let's manually select that. Let's manually select our points from top A. Oh, I can't use A. Oh, that's why I had to convert it into a primitive. Okay. That's why I did all that fancy stuff. Okay. So we need lines over there, over here in this attachment here, in order to use that A trick. Let's see. Okay, we're running on a really long stream again. Okay, you know what? I'll just show you the manual way of doing it, and then the next time I'll show you a trick onto the setup is quite, you know what? Let's just do it right now. Let's just do it right now. What you can do, let me show you the manual way first. It seems really silly. Let's go here and just gonna click, 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 click. You have to click it in order. We can't use the A trick because these are not connected anymore. There's a way to convert it into lines and convert it back and forth in order to maintain that the stuff. Okay, see, this is what I need. And then when you run it through the whole simulation, let's try it. Okay, it maintains it a bit better. Well, let's see. Okay, let me run this. I can't find my Vellum Drape. Okay. This one is actually a lot better, this one. So this is my cheat sheet. My cheat sheet is a lot better. Stitch line here. So this is my stitch line. Cloth here. Change constraints. Oh, the rest scale. Right. Let's change the rest scale down. Of the attached geometry. Let's change the rest scale down so it squeezes it a bit. The rest scale, what the rest scale does, this having it 1 maintains its what do you call it? Its original shape. If we lower it, it will change its shape a bit. Either larger or like squishes it more. And this, yeah, this is a lot better. So this is a bit, it's sticking to the shape of Tommy a lot better. So it's sticking more. As opposed to, let's do it again. Oh, you know what? I should take a screenshot. Yeah. No, I'm going to do it again. Let's do it. And after this, I'm going to close off because I'm really tired. And we can continue this on in a couple days, I guess. As opposed to this and the screenshot. Let's bring it over. Oh, let's maintain that same angle. Okay. Okay, yeah. So this is, look, this edge here is sticking very close to the thigh. This is all the way to the side. So by reducing the value of the rest scale, it's squeezing it more towards, it's adding more force toward that attachment constraint line. Oops. Okay, let me check the chat. And we're going to close it off like this. I'm sorry, I didn't get enough time to finish it all. You can't move the island and shape it like you want. Move the island, the UV island? You can. There is a UV transform. I guess you can manually align it like that. Yes, you can do that. But the way, okay, today I ran out of time. What it would look like, I'll show you the finished product because the one that we're working on is not there yet. So you are talking about this. This here, and then I flip it so it's like this. Flipping it back like that is actually really easy. I'm not there yet in the live stream. Let's see, here's that. Okay, let's template that, and I'll show you. This is before flipping it. So this is before flipping it. Then this is all that takes to flip it. These two transforms, a split and the two transforms. So it's not that hard, and you get really accurate results like that. Like flipping it in here. I don't know. I don't know how. Then you gotta like pay attention to the front and back and the reverse UVs. Like you don't know which side is the front and which side is the back staring at this. I would much prefer staring at this and eyeballing it. Well, not eyeballing it. This is not eyeballing it because it is this rotation. It's because I used a Houdini expression here to get the exact pivot point on, let me see if I can visually show you where the pivot point is. Let's see. The pivot, okay, there's the pivot point. Let me bring back. Okay, yeah, this is it. This is here. So there's the pivot point. I'm telling it. Oh, that's not the here. Okay, that's better. You know what? Let me just do this. No. Okay. There's the pivot right here. The pivot of the X is all I'm concerned about, where this is at. It's pointing directly at the maximum X axis. That is of this geometry, of the previous geometry. So in here, I put in a 0, which is feeding it from this input. So the pivot is starting here. Oh, sorry, here. And we're flipping it. And we're flipping this piece back like that. So let me show you. Let me show you. If I take this, that's what it looks like. And 180 degrees back is exactly that spot right there. It lines up perfectly. So that's why I suggest using this way. It's actually not that hard. It's just I never managed to get there yet. So okay, last call for questions. I'm gonna end it off after this. So if you have a question, just shoot it into the comments. We're gonna continue. I know I'm not done. Like, this is not complete yet. There's more to this. We're almost there. Didn't quite make it through. It needs another stream. But I'm here to answer any questions left first. Evgeny, I'm sorry if I got your name wrong. Can't we do the planar patch thing in a for loop, all the pieces at once, so we can control it in one place, or just need to separate back and front? Oh, let's see. Let me go back. What did I do? Here? Oh, this? I only separated it here just so I could punch a hole through this here. That's all I did. So because I only want to punch a hole in the torso, the front, not the back. So that's why I split it here. I mean, it doesn't really matter too much because this box never reaches the back. If you look carefully, this box never goes that far. But just in case, who knows? It's just an extra caution to split it, because for sure this will never cut a zipper line onto the back, because the back geometry is in a different branch of nodes. So this is just a precaution. Seriously, if I did it like up here, oh, you know what? I can just, yeah, if I can just ignore the split. So we have both of them here. Oh, right. So oh, it might actually matter. Actually, it does matter. Because, okay, when we're putting it all together, and I'm using a procedural way to find the zipper line. I'm using the size of the patch to find the zipper line in order to put the box in, because this is a bounding box size. It's actually taking the size of the entire geometry, including the back. So it will matter in this case because I used this way of doing it. If you did it manually, if you manually put down the box, like if you didn't do this and you manually shaped it in yourself, like with these controls and all, and you manually put the zipper line in like that, it won't matter. But because I used the procedural way to do it, I'm relying on the size of the front piece in order to place the cutting line of the zipper line. The cutout for the zipper line. Samsor, hi. Hello. We're actually about to end it off. RBLX, is there a belt function in it? I'm not sure what you mean. Can you clarify? To fixing some points from the cloth. Yeah, I'm sorry. I'm not sure what you mean. Yes, I mean the UV islands, because normally it's possible to move the UV island and even the points, so even to fix your geometry. It is. They do have that. It's possible to move your customs and weld it. Yes, you are correct. There is that. Here, let me show you, because this one is perfect example. Let's do this. Do we have that there? If I want to move the UVs of this guy, there's Houdini comes with all sorts of UV tools. You can use the UV transform, is the one that have experience with. I don't manipulate UVs that much. I try not to. Select this, come over to your UV view over here, press enter, and then you can like move it around. You can rotate it. You can do whatever you want with it. You can select, okay, let me undo that first. You can select only the front. So I only want to move the front. Let's go like that. Okay, let me do it again. The front group primitives. It should. Let me see if my group still exists. I might have lost it back all the way down. Front. Yeah, I lost it. So the group is lost because this planar patch is new geometry. So the group is lost. Let me put the group back in and let's redo that. Let's remake the group front. Let's take this out. And this is the back. Let's move this up. Okay, let's do this again. Let's do the UVs. So I want to move the front. So I take this, selected this, the front, front here, and come over here. And I'm going to press enter. Now move this around. There you go. You can move it around. You can rotate it. You can do whatever you want. You can even, let's see. Let's do this. You can manually select this, I believe. One second. Why isn't this working? Okay, it's not letting me select it. Houdini. Fine, let me do it. Let me force you to let me. Yeah. Lasso. Can I just select it like this? Okay, that works. Okay, group 7. So I just want to manipulate group 7. Okay, and then come here. There you go. And then you can align it like this, but you're going to have to eyeball it. I don't know. There's other tools. There are other UV tools that you can use. Now, I'm not very proficient in UV manipulation. I try to avoid it at all costs. I'd rather manipulate this geometry and then just project it on as best as I can. I find that works well in my workflow, but whatever whatever works for you. Everyone has their own style. Oh, great. Okay, good. Awesome. There's actually other applications that does UV manipulation. I can't think of any on top of my head because I I've never wanted to use them. But there are actually, oh, I think it was called, oh no. It's on the tip of my tongue. Okay, now that's gonna bother me. Let me quickly look that up. Oh, marmoset. I think that was it. Was it? Marmoset? I'm not sure. Was it this one? I think they have excellent topology tools. I'm not sure if they do UVs. I think it was this one. Well, anyways. Rinsum. Oh, yes, Rinsum is run. Yes, you're right. Rizum. I have no idea how to pronounce it. I'm terrible at pronouncing names. But Houdini has been pushing that because I've seen it here. I mean, that's as close as I know what it does. Like I said, I try to avoid it at all costs. Maybe one day in the future. It seems overly complicated. Just for UVs. I mean, we have to texture it. We have to model it. We have to texture it. And now we have to fix the UV like this. Oh my God. And then you have to topologize it. Too many steps. I just want to do something simple sometimes. All right. If that's all the questions we have, rise on is how most people pronounce it. Awesome. Thank you. Thank you for telling me. That comes in handy. I will remember that. Rise on. Okay. Thank you, Timothy. Thank you. Okay, if that's all the questions we have, I'm gonna call it quits. We're gonna finish this in another time. Yeah, I'm not gonna say a date because it may not happen if I say a date now. It's probably going to be this week. I want to get this over with. I'm really looking forward to facial mocap with a webcam. That to me is incredible. Like, you don't need a fancy iPhone. What is it called? True depth camera or anything just for the facial mocap. I mean, it gets pretty expensive. I know it's already cheap. I know it's already affordable to this day and age that we can do a whole like studio set in the comfort of your home, but it's still expensive. If I can minimize it to just a webcam, because I've seen a lot of open source open source projects, and I tried some of them out. They work really well. I mean, you're gonna have to pay a bit. You're gonna have to buy the camera. You'll need a nice webcam. But I did try it on a very earlier project I did. Let me pull it up because I really like this topic. Oh, that's not helping. This one. This is the video that I did. I used a really cheap camera and it still worked pretty well. But I was so inspired with this project that I went out and bought a nicer webcam. What I read online is that you need a webcam with really high FPS. Resolution is actually not that important. The FPS is important. So I haven't had time to try that out yet to continue that project. But if that succeeds, I think if I can accomplish that, I think that would be really nice. I think it would be helpful for a lot of people too, to lower down to make it more affordable. You can imagine if you're a director, you can hire people online and then go like, can you send me this footage of you doing funny, acting this script out, and I'll take that and feed it into my scene, as a facial mocap scene. You can imagine how much we can create a movie just remotely with all remote actors. And the actors won't have to buy a fancy iPhone. I mean, most people have iPhones already, so I guess I don't know. So cool. I never thought you can UV stuff in Houdini mocap through Houdini or a separate program. It's an open source program. It has nothing to do with Houdini. It's just something I'm experimenting with. I buy Connects 2.0 to do mocap, but I need a USB card with Intel chip. Oh, you don't. I have the Connects. I bought 2 Connects. They're really hard to find. The first Connects I bought was really cheap. The second one, they jacked up the price like crazy. It was like double the price. So if you want a Connects right now, buy it now. Don't wait. Because the Connects are just going, the prices are just going up and up and up. It doesn't matter what, it's aging, but it's still, the price is still going up. To do mocap. Yes, Connects can do body mocap. But facial mocap, I find that it's not very accurate. It's really bad. You don't need a USB card. You need that fancy adapter. I actually made a blog post on it. The adapter is really cheap on Amazon. Now, you need to know that the ones on Amazon are not made by Microsoft. They're made by third-party vendors. Like, I'm guessing they're people at home, or I don't know who they are. There's tons of them. So pick the one with a nice rating. You don't want it to explode. I hope it doesn't explode. The one that I used is fine. Like, I've been using it for a couple of years and nothing's wrong with it. But I never leave it unattended. So if you have it plugged in, always keep an eye on it just in case it overheats, because it is like, it's made by a third-party vendor. It's not made by Microsoft. I'm trying to find that link. Let's see. Okay, here it is. This one. You come to my homepage. There's a search bar. Scroll down. There's a search bar here. Just type Connects. It'll be the first thing that comes up here. Come on. This one. Just be the first link. And that'll take you over here. So this is I used KneeMate at the beginning. Oh, just FYI. KneeMate does not work well with 2 Connects. Just so that everyone knows. I really should put a message here. KneeMate works excellent with 1 Connects. 2, not that great. So I used, what is it called? I don't remember. Oh, this is what I'm talking about. You need this. You need these, this one. You need these aftermarket adapters. Now, the one that I bought, they don't manufacture it anymore. But there's tons of these. Like, there's so many different brands online. Let's see. Just be aware, they're aftermarket, so they're not made by Microsoft. Microsoft had discontinued the Connects and all accessories to the Connects a long time ago, so you're not going to find that anywhere. I will watch your video after this here. Video? Oh, that thing. Okay, I'll put a link in the description. Oh, that, you're talking about this guy, right? It's like 1 minute. It's just a teaser video. You don't have to watch it. Here, I'll put a link actually, so you don't have to search for it. Here. I built the adapter myself. I bought the Connects 2 years ago, but never go into it. Yeah, I know that happens. I buy a lot of stuff too, and I never touch it. Your USB chipset need to be Intel readiness. It will not work. Other chipsets will have to be, I'm not sure. I don't have an Intel chip. I have an AMD chip. It works fine. I don't know. I don't know what this means. You do have to update your driver, if that's what you're talking about. I'm not sure. I think if you have Windows 10, it should be okay. You just need to update your driver, and you have to install the Microsoft SDK. What do they call it? The Microsoft Connects SDK, and the driver, the corresponding driver. Cool. All right. If there's no more questions, I'm gonna just end it off. Thank you all for joining me, and I'll put a announcement in somewhere probably in the communities tab, announcing when to do part 2 of this, and we can finish up this vest. No, the USB chip hardware side will not work without 100%. Okay. All right. Orange P. Thanks again for the stream. I learned a lot. Also, thank you for the flip tank and river tutorials. They inspired me to learn Houdini. Have a good evening. Awesome. Thank you. I'm glad it helped some people. The flip tank and the water ones are very well received on my channel. I guess everyone likes water. They're very heavy. They're RAM eaters. I don't have much RAM. But the narrow bands on the flip tank are awesome. This optimizes the flip simulation so much. I'm so glad you like it. So thank you for joining me tonight too. Thanks. See you next time. Yep. See you all next time. Thank you for joining me.